What if we lived in a world where we still believed that light came from our eyes? It sounds strange, but that was the belief of ancient Greek philosophers. Empedocles, for example, thought that light was a substance emitted by the eyes, allowing vision by interacting with objects. Plato and Aristotle also had their own curious ideas. Plato believed that the light from our eyes met the fire of objects, while Aristotle saw light as a necessary condition for vision, without fully understanding its nature. Have you ever stopped to think about how the world would be if these ideas were still accepted? Imagine the changes in our technology and understanding of the universe if we still believed that light emanated from our eyes. Perhaps we wouldn't have telescopes or microscopes, and our comprehension of the cosmos and the microscopic world would be limited. We might believe that looking directly at the sun increased the emission of light from our eyes, possibly leading to strange practices to protect this supposed internal source of light. This thought could even affect our art and culture, with representations of glowing eyes and artworks symbolizing the internal source of light and knowledge. The Renaissance brought a true scientific revolution with figures like Isaac Newton. In the 17th century, Newton showed that white light is composed of various colors that can be separated and recombined with a simple prism, like when sunlight passes through a glass prism and turns into a rainbow. He proposed the corpuscular theory of light, suggesting that light was made of particles. Imagine the fascination and surprise at discovering that something as common as sunlight is, in fact, a combination of all the colors of the rainbow. But in the early 19th century, Thomas Young and Augustin Jean Fresnel, with their experiments on interference and diffraction, surprised us again. Surprise! Light is both a particle and a wave. Think about how ocean waves can overlap and create patterns. They showed that light does something similar. This concept challenged the scientific minds of the time and opened doors to a new era of discoveries. Let's move to the late 19th and early 20th centuries. James Clerk Maxwell and Albert Einstein took fundamental steps towards our modern understanding of light. Maxwell unified electricity and magnetism, showing that light was an electromagnetic wave. Imagine realizing that the light we see is just a small part of a vast spectrum of electromagnetic radiation. Einstein, by explaining the photoelectric effect, introduced the idea of photons, small particles of light. Who would have thought that light would have an identity crisis? From ancient Greece to today, our ideas about light have evolved drastically. The theories of Empedocles, Plato, and Aristotle, though rudimentary, laid the foundations for Western scientific thought, which would later be revolutionized by Newton and his successors. Can you imagine still believing that light comes from our eyes? The major advances in the study of light include the discovery of the component colors of white light by Newton, the wave nature of light revealed by Young and Fresnel, and the unification of electromagnetism by Maxwell. Each discovery brought us a more detailed understanding of light. Einstein's discovery of photons and the wave-particle duality paved the way for modern physics and technologies like lasers and fiber optics. These changes in the understanding of light profoundly impacted technology and daily life. The wave theory allowed the development of communication technologies like radio and TV. The discovery of the electromagnetic nature of light led to the invention of devices like microwaves and radar, like those used to quickly heat food or track airplanes. And Einstein's photons? They propelled the creation of modern technologies like lasers used in medicine, telecommunications, and entertainment. From watching your favorite show to having eye surgery, all this is possible thanks to these discoveries. The understanding of light was also essential for astronomy and space exploration. Optical telescopes, since Galileo, have allowed scientists to uncover many secrets of the universe. Have you ever thought about what it would be like to try to observe space without these instruments? Radio telescopes capture radio waves emitted by space objects, allowing the discovery of phenomena like pulsars and black holes. The Event Horizon Telescope gave us the first image of a black hole. Does anyone else think black holes are the perfect mysterious villains of the universe? Spectroscopy, which analyzes the light emitted or absorbed by space objects, allows scientists to determine the chemical composition, temperature, and movement of these objects. This technique is vital for studying exoplanets and searching for signs of habitability. Who would have thought we could know so much about planets light years away just by looking at their light? Optical telescopes and radio telescopes revolutionized astronomy, allowing discoveries that were previously unimaginable. If you could use a state-of-the-art telescope, what would you like to see? The surface of Mars with incredible detail? Or maybe the turbulent atmospheres of Jupiter and Saturn? Light is not just a physical phenomenon, but a rich symbol in various cultures. In ancient Greek philosophy, Plato used light as a metaphor for knowledge and truth. During the Enlightenment, light symbolized reason and progress, and in religion, light often represents the divine and spiritual enlightenment. Have you stepped out of your cave today? In art and literature, light also plays a fundamental role. Painters like Caravaggio used the contrast between light and shadow to create drama. In literature, light symbolizes hope and revelation, as in Dante's Divine Comedy. Who would have thought light could tell so many stories? Artificial lighting transformed modern life, allowing nighttime activities and altering our circadian rhythms. Illuminated cities created new social and economic habits, but also brought challenges like light pollution. What would the world be like without city lights? Sunlight is crucial for human health, helping in the synthesis of vitamin D and regulating our circadian rhythms. Maybe that walk in the park is more important than you think. Light plays an essential role in photosynthesis, the process by which plants transform sunlight into chemical energy, sustaining almost all life on Earth. Without sunlight, what would happen to our crops, forests, and consequently, the food chain? In short, light is fundamental to life on Earth, playing a central role in essential biological processes like photosynthesis. Have you thanked a plant today? If not, now is a good time to start. From antiquity to the present day, the evolution of ideas about light reflects how our understanding of the world can change radically with new discoveries. And who knows what still lies ahead? Science is constantly advancing, revealing mysteries of the universe that were once unimaginable. Perhaps the next big discovery about light is just around the corner, waiting for a curious scientist to unveil it. If you enjoyed this journey through the history of light, don't forget to like, subscribe, and share your thoughts. See you in the next video.